everyone, this is my demo for 7A target. This is a combinational circuit, and the one I chose to do is a real whole number that is an odd number that is less than 9. So three things: real whole number, an odd number, and less than 9. So I went ahead and found them here first, so that way I know which ones. And then this don't care numbers are later when it comes to the S output, but first we're going to talk about the two outputs, Q and R. And we have a 4 input with 4-bit code for our truth table here. So first we're going to start with the truth table for Q. So for Q we have all the odd numbers is what I chose Q to be. So you can see that here, them listed as 1, 3, 5, 7, and so on. And then I went ahead and made a K-map for Q, and that is over here. So let's do a couple of those. For in this truth table, we have 0, 0, 0, 1, and so we have 0, 0, 0, 1, and that comes to here. And then for another one, we'll do 7. We have 0, 1, 1, 1. So 0, 1, 1, 1, so that'd be here. So, and you just fill that in throughout the whole thing, and then we get a nice grouping, which is a group of 8, and that leads us to this equation because D is the only one that remains constant in this grouping. Next we have our R, and for our R, that is anything less than 9. So from 0 to 8. So we're going to go ahead and put that into this K-map over here, and then we'll just do a couple. So we have all zeros across the board. That is our first box. And then we'll do the last one, 8, which is a 1, 0, 0, 0. So 1, 0, 0, 0. That comes to here. And we get a couple different groupings with this one. We have this group here of 8, and then we have another group here, which gives us a wraparound method. So we have to have a group of 2 at the minimum, and that is the biggest group that we can get, including this one. Then we get this equation down here, R equals A naught plus B naught, C naught, D naught. Now we're going to move on to this S output. So this is just a combination of the two. So we get a combination of Q and R that gives us S. So that's going to be all the odd numbers that are less than 9. So that gives us 7, 5, 3, and 1. And then we still want to include numbers that give us a positive output from Q, but we don't care about them. So that's why we have X's here. So these are our don't care numbers, which you can see here. At first I thought we needed to include 10, 12, and 14, but those are not odd numbers, so we don't include them in our don't care numbers. So that gives us this K-map here. And so we have our don't cares down here, which is these 4, and then our ones up in here. So we get a nice grouping of 4 here, and then that gives us this equation here, S equals A naught D. And you'll see this in the circuit here in just a minute. Okay, so here is our circuit. We're going to go ahead and start with just going through the truth table a little bit. So we're going to start with 1, that turns on all of these lights. And then we have 2, 3, 4, 5, 6, 7, 8. And that gives us all the numbers less than 9, but what happens when we do 9? So R turns off, Q comes on, and S stays off because it's a don't care number. And that is it for our circuit.